Hey everyone, I hope you had a great weekend. And I want to start, we are going to go into 7.3, part 3, which is the last part, I promise, of 7.3, which will be subtracting rational expressions with unlike denominators. We did addition and reviewed that last week. But I want to start, you're going to see this example on the screen. I'm seeing some of you that when you're trying to like simplify your final answers, some of you are still trying to do this, and I want to show you that in this example right here that I just boxed in red, if you're trying to do what this student did, which is they got an answer of x squared plus 7x plus 6 all over x squared plus 5x plus 4, you need to simplify that. And by trying to just cross out these x squareds, that's not okay. X squared is not a factor, it's the leading term of the trinomial. So you cannot do that. So what I want to show you is that if you're still the person or students that are doing this, please stop because you're getting wrong answers, okay? So this is not correct. What I want to do is show you how to correctly simplify this. And y'all, that really means factoring. So I'm going to factor the numerator, x squared plus 7x plus 6, into x plus 1 and x plus 6. And then I'm going to factor the denominator into x plus 1 times x plus 4. Now, once the numerator and the denominator is factored, like if you're trying to simplify a final answer, you can cancel out common factors. So the true answer to this problem would be x plus 6 over x plus 4. I just wanted to review that before we go on so that you're not running into those issues. Okay? All right, so you will find this handout in Canvas, just as you found this video. It's right above it, the link. So we're going to go ahead and dive right into this. So we're going to try to get through all 5 of these examples. So what we want to do is we're subtracting this time, and it's very similar to addition, but students tend to mess this part up because of the subtraction. So if you look at your denominators, we have an x and a 3 times x. So our common denominator would be 3x. So I'm going to multiply this first fraction, okay, by 3. So that way that gives me 15 over 3x minus 2 over 3x. Some of you are trying to cancel right now. Like right now, some people are like, oh, look, 15 divided by 3 will cancel. But the problem is then you're not going to have the same denominator and you're back to where you started. So we definitely want to make sure that you write the common denominator and then actually do what's on the top. Now this one's not going to be too bad because you're just subtracting away a number. So 15 minus 2 would be 13 over 3x, and that is simplified. Okay? All right, let's go on. All right, I was having technical difficulties. Okay, so let's go ahead and move on to number 2. So in number 2, we want to make sure that we're going to factor the denominator first before we can figure out our common denominator. So I'm going to factor out a 2, and I'm left with x plus 4. And then over here, I'm going to factor out an x, and I'm left with x plus 4. So it looks like our least common denominator is going to be 2x times x plus 4. So 2 times x plus 4. So it looks like what we're going to do is we're going to have to multiply this first fraction, top and bottom obviously, so let me kind of include this. So we're going to multiply this. Well, we already have 2 times x plus 4, but we need this x. So we're going to multiply this by x over x. And then this fraction over here, it has x times x plus 4, but it needs the 2, the factor of 2. So we're going to multiply by 2 over 2. Okay, so now on the denominator we have 2 times x plus 4. And the numerator we have x times x, which is x squared, minus the denominator 2 times x plus 4 should be the same. On the top we have the 2 and times the 8, which is 16. Once again, make sure, and I think it helps to kind of write the denominator so that you don't cancel anything out. And then we're literally going to subtract x squared minus 16. So right there, what we've done is we've actually subtracted, but now we need to simplify, and this is where some of you are just kind of stopping. So to simplify, x squared minus 16 is a difference of squares, if I can talk. So that's x plus 4 times x minus 4, and the denominator is 2 times x plus 4. So as you can see, your x plus 4s are going to cancel. So your final answer would be x minus 4, x minus 4 all over 2x. All right, so example 3, we're going to start the same way. So in that first fraction, it looks like the denominator can be factored. So we have 5, factor out of 5, so we're left with x minus 2. So a lot of times it's not a shocker. You're like, oh, I see an x minus 2 in the right fraction. So that means we don't have to multiply anything by this first fraction because our least common denominator looks like it's going to be 5 times x minus 2. Well, we already have a factor of x minus 2 in the fraction on the right. So what we're going to do is we're going to multiply this fraction times 5 over 5. So what that gives us is we have x squared plus 16 all over 5 times the quantity of x minus 2 minus 4 times 5 is 20, and then that gives us 5 times x minus 2. I highly stress, once again, that you go ahead and write one fraction bar with the common denominator. Do not cancel anything right in this area where my little mouse is showing, because then you won't have a common denominator and then you have to start all over, so it just becomes a mess. So on the top we have x squared plus 16 minus 20. So that's going to give us x squared, a positive 16 minus 20 is a minus 4, all over 5 times x minus 2. So you're almost there. So we're going to simplify. We have a difference of squares, x squared minus 4 factors into x plus 2 times x minus 2. And then we have 5 times x minus 2, our common denominator. So now you can see that you have two binomials that will factor into each other to 1. So your final answer to number 3 is x plus 2 all over 5. All right, example 4. Now this one is a little bit different because if you look at the denominators, x plus 3 and x, there's nothing to factor. So our least common denominator is actually just going to be the two denominators multiplied together. Okay, it's almost like saying you have a 2 and a 3 as your denominator. What would be the least common denominator? Well, 2 and 3 both go into 6. 2 times 3 is 6. So what's going to happen is this denominator needs the factor of x, which this one has, and this fraction needs a denominator of x plus 3, which is what the first fraction has. So let's go ahead and do the multiplication. So we have x times x, which is x squared, and here we have an x times x plus 3, we're just going to leave it in factored form as we've been doing this whole time, minus 4 times the quantity of x plus 3, that's coming from 4 times this, and the denominator is the same, which is our whole purpose of x times x plus 3. Now, this is what worries me. So, that alarm system is going off, ding, 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 because this is what scares me, okay? So this is where I see students who mess up a little bit compared to addition that we did last week. So I'm going to write x squared minus 4 times x plus 3, all is one fraction. So you can see I have one fraction. Now what scares me is a lot of you are forgetting that you are going to distribute a negative 4. So what we have, I'm going to get rid of this. So what we have now is we have our numerator of x squared minus 4x minus 12 all over x times the quantity of x plus 3. Now, some of you who are a little bit more advanced might realize that this is actually simplified, but I need you to continue on. So what I mean by that is let's factor this numerator, what multiplies together to give us negative 12 and adds to give us negative 4. Well, that would be a minus 6 and a positive 2. Now, that does factor. Now, you may be thinking, well, that's a waste of time. No, because you're checking your work. So right now, I factored the top and bottom. Now, nothing cancels, and that's okay, because at least you checked. And that would be your final answer. All right, your last example of subtracting rational expressions with unlike denominators. Now, x plus 2 is the denominator of the first fraction, and x minus 2. All right, remember, factors are things you multiply together, and we're looking for the least common denominator. So once again, we're going to have a least common denominator of x plus 2 times x minus 2. So this first fraction already has the factor of x plus 2. Well, we need it to have a factor of x minus 2 in the denominator. And then the second fraction already has a factor of x minus 2. So we need it to have a factor of x plus 2. Okay, let me make it look nice. All right, so we have a common denominator. Let's show that. So I'm going to write this out the long way just so you see. So we're going to multiply x minus 2 times 6. I'm just going to write it how we typically see in algebra 2. All over x minus 2 times x plus 2 minus 3 times the quantity of x plus 2 all over x minus 2 times x plus 2. Do not cancel anything. You can't. Otherwise, you won't be able to subtract, and you won't have a common denominator. So right now, I'm going to write this so that we have one fraction, meaning the common denominator is the same, so I can subtract. And I'm going to write this out in probably a longer way than some of you would do, just to kind of show you since I'm your teacher. So right now, we're going to distribute 6x, or 6, I'm sorry, to the x minus 2. So that's going to give us 6x minus 12. Now, right here, I'm going to put it in red. This is a minus 3. So you're distributing a negative 3. So that's going to give you minus 3x minus 6. And then all over our common denominator. So when we actually do the subtraction on top, we have a 6x and a minus 3x, so that's 3x. Here we have negative 12 and negative 6, so negative 12 minus 6 is minus 18. Now, technically, I can kind of look ahead and know it's not going to simplify. However, the top can be factored, so I'm going to take a 3 out, and I'm left with x minus 6. Now, none of the factors on the top cancel with the factors in the bottom, but at least we did our job and checked it. So that would be your final answer. Okay, so that officially wraps up 7.3, part 1, 2, and 3, and you'll have a chance to practice just a couple of these for an assignment. Okay, good job.